So welcome to the pharmacology class, and today's topic is the cholinergic agonists. And most of the drugs are not clinically important, but it is important to understand how they act on the cholinergic nerve, because the same principles are uh, valid for other drugs. So the cholinergic agonists are divided into two types: direct acting and indirect acting. So direct acting cholinergic agonists are mostly useless, uh, with the exception of nicotine and piligrapine. Nicotine is used in smoking cessation, and piligrapine is used for the glaucoma. Other agents are used seldom, but they are important, and because, for example, acetylcholine is synthesized in the body, and carbachol and beta-nickel sometimes are used in the surgery. And indirect acting agonists are also used for the same indications, like for glaucoma, and they are also used in surgery. So these indirect acting agents are also important, and there are also indirect acting. They are not used completely, and the reactivation of acetylcholine esterase is the antidote for the poisoning. Palidoxime is the antidote. So these are the drugs that are used as a cholinergic agonist, and the drug names are acetylcholine, beta-nickel, carbachol, sevamyline, nicotine, piligrapine. These are direct acting. Indirect acting include also imidonium, donepezil, endorphinium, galantamine, neostigmine, lisostigmine, pyridostigmine, and rivastigmine. Echotiafat is not a drug actually, but is completely not. It's not used and approved in some countries. So these are the drug names. Please be sure you remember them by heart. And this is a picture from the previous lecture. I hope you're familiar with that. And most of the drugs that we will discuss today will act on cholinergic receptor, and they act on the ganglia and on the muscarinic receptor, on the postganglionic of the parasympathetic nervous system. So also for the somatic, but this is used rare than others. So this is the structure of the whole autonomic nervous system. So we mostly act on the parasympathetic nervous system, because most of the agents are M-cholinergic receptor agonists, so they only act on muscarinic receptor. Some of them also act on nicotinic and are not selective, but selective one act on muscarinic. So, and this is the structure of the muscarinic cholinereceptor, and cholinergic receptor choline receptor is synthesizing acetylcholine and keeping it from the choline with the help of the acetyl coenzyme A, and acetylcholine is kept in the vesicles before the entering calcium ions will stimulate the uh, release of these vesicles into the synaptic cleft, and after the release uh, the acetylcholine can uh, activate the presynaptic receptor, sorry, or postsynaptic receptor. So um, there are some toxins that act on the release of the uh, acetylcholine, like the botulinum toxin and spider venom. So if you are in the desert in Egypt, in Sahara, so and if the spider will bite you, then probably you will need more. So you could not able to release the acetylcholine, and then you will die because of that. So there are also uh, drugs that block the retake of the that block the retake of the choline, because the choline is uh, the choline uh, is taken back uh, to synthesize acetylcholine again after the release, so it's recycled, and the acetate will go to the blood. So acetylcholine is divided to acetate and choline. Choline goes back to the presynaptic ending, and the acetate will go to uh, the blood. So then most of the drugs will act on the postsynaptic receptor and prevent binding of acetylcholine. Um, that is the primary action of the most antagonists, but we will talk about them next week. There are two types of the receptors, muscarinic and nicotinic receptors. Muscarinic receptors have high affinity for the muscarine, the upload of the uh, uh, upload of the uh, fungi, and acetylcholine is the and nicotine are both the androgenic agonists. And acetylcholine have a high affinity for the uh, muscarinic, and and nicotine have a high affinity to the nicotinic receptors. So that is why nicotine will not stimulate the muscarinic receptors, so that they will not fit. And then the nicotinic receptor is uh, is stimulated by the nicotine and also by the acetylcholine, because acetylcholine is a non-selective, so it will stimulate both muscarinic and nicotinic receptor, but muscarine will not stimulate the nicotinic receptors. So this is the selectivity of the two types of the receptors. And the acetylcholine is not very stable, and it is hydrolyzed by the acetylcholine esterase, and so this is the molecule of the acetylcholine, and the structure is the the fourth tertiary amine with the ethyl and oxygen bridge, and then acetyl part. So this is acetyl, that is why it's called acetylcholine. So this part is acetyl and this is choline. They are connected with the oxygen bridge, and the nitrogen is positively charged, so the molecule is positively charged, so will not cross through the membrane, so it requires some transport system to release. And then the derivative of the acetylcholine is beta-nicole, and it is no more the ester, so it is the ester of the becomes an ester of the carbamic acid. So instead of the the ester is complex, so the nitrogen here will lead to the redistribution of the electronic electrons, and that makes make this bond stable. So that is why the beta-nicole is not hydrolyzed by the acetylcholine esterase. So, and this as well as the carbonyl, so they both resist to the acetylcholine esterase. And they act longer than the acetylcholine. So these are resistant to the enzyme. And pilocarpine is also resistant to the enzyme because the structure is completely different, and pilocarpine is obtained from the lungs, and is used for the treatment of the glaucoma as eye drops only. So pilocarpine has similar structure, the nitrogen, some alkyl, and the two rings, but the size of the molecule is approximately the same as the acetylcholine. Also there is a nitrogen here, so same as here, and these two carbon atoms like this one, and then oxygen here, so they are alike, not much, but so alike here also. So these structures with the ring, but they fit the receptor anyway. And the adverse effects for the muscarinic agonists include the diarrhea, diaphoresis, so sweating, profuse sweating, meiosis because of the contraction of the ciliary muscle, nausea with the diarrhea, and urinary urgency because the acetylcholine and cholinamimetics will stimulate with the smooth muscle of the urinary And so these are non-pleasant side effects. And the second type of the drugs is the uh, irreversible, the indirect cholinomimetics. And the indirect cholinomimetics will not uh, bind to the receptor, but they will act uh, uh, on the inactivation of the acetylcholine. So normally acetylcholine is hydrolyzed by the acetylcholine esterase to the acetate and choline, but the indirect polynomimetics will block this enzyme and prevent acetylcholine from the hydrolyzation. So, and then neostigmine and physostigmine, most commonly used, will prevent this process. That is why the acetylcholine will act on the receptor. So, and unless the all acetylcholine is depleted, then the neuron will be stimulated, and that will lead to the contraction. So these are indirect acting, and indirect acting have also the adverse effects that include the contraction of the abdominal muscles, meiosis, the same as for the direct acting, and hypotension and bradycardia. So these are adverse effects for the physostigmine actually. So that's all for today. Do you have any questions? Ahmed, we just completed with the lecture, so do you have any questions?
No, thank you.
So those of you who missed the lecture, please watch online. The link is available at the educational portal. No questions? Then thank you for attending and see you next week.
See you.
Bye, teacher.
Bye bye.